My name is Zhuoya. I'm a PhD student at New York University. I'm here to present paper 210 on ontology towards BIM-based guidance of building facade maintenance. Facade condition is very important to public safety, especially in densely populated cities. There are major cities in the US have mandatory facade inspection programs. However, even with the facade inspection programs, accidents and incidents are still happening in these cities. Besides the accidents and incidents, the New York City Department of Buildings keeps receiving complaints about facade problems. These facts indicate a need to improve the current facade inspection program. From our shadowing work with inspectors, we found out that current inspections need systematic guidance for a comprehensive inspection. For example, for one building in our shadowing work, Inspector 1 mentioned about a setback on the 5th floor, but did not check for the height. The second inspector estimated for the height and noted that it's a non-code compliance parapet. The code compliance checking was required by rules of the New York City. Besides the difference of information collected during the inspection, we also identified different grouping styles in the when the inspectors report their inspection findings. Some inspectors group all their related defects under the facade component. This is a natural way of organizing based on the inspection practice. Some inspectors prefer to group all related components and locations under the same defect type. This is based on the repair needs. The grouped information can be used to guide owners for repair and maintenance on facades. There's also a mix of the previous two grouping styles. Examples of these grouping styles are included in the backup slides due to the time limitation. To resolve the identified problems, we envisioned a model-based comprehensive checklist to guide the inspection practice. Based on the project information, a comprehensive checklist can be generated to guide the inspectors. A flexible data management approach will also be developed so that the inspectors can group their inspection findings based on individual preference. This paper focuses on the generic and the extensible facade inspection ontology development. We developed the ontology by first performing the shadowing work with experienced facade inspectors and then review the relevant documents and analyze the historical facade inspection reports. We also investigated the necessary clauses, attributes, and relationships for model-based checklist generation and the flexible data regrouping. Existing data standard and the specifications were also investigated for the capability to represent the identified clauses and relationships. This step aims to understand whether we can use some of the clauses as is instead of creating the representations from scratch. One outcome of this research is the developed facade inspection ontology. Here is a part of the ontology that covers the information required by inspection ordinances, such as code compliance checking, violations of the building, and the inspection history of the target building. Also, facade decompositions. The inspector may decompose the facade based on their inspection approach. If they are doing the visual inspection with a boom lift or a road drop, they may decompose the facade vertically. If they check the surrounding facade with from balcony, they may decompose it horizontally by floor. And facade components. The facade components entities covers the hierarchical organized facade components that need to be included for a comprehensive inspection. Also, defect type and attributes. Here, defect attributes are provided as defect property set. The next slide will provide details about these major entities. IFC schema is being utilized to represent buildings, floors, building elements, and the geometrical spatial relationships that are needed for the inspection purpose. In our shadowing work, we identified 3 major information groups: facade component, defect types, and the defect attributes. By reviewing the related documents and analyzing reports, we combined a hierarchically organized vocabulary of facade components and the defect types. Here, there are 4 levels included for the facade component class. Here is an overview of the level 1 and 2 major categories of the facade components. Numbers in each cell indicates how many components are included in level 4, which is the most detailed level for facade component class. Defect types varies based on the applicable facade types. Buildings in New York City are classified based on their facade material. The applicable defect types are classified into 3 categories: material loss, deformation, and the surface color and texture change. Material loss defects refers to presence of defects where the facade material, for example, brake unit and a motor joint, was lost. The most common ones identified in this category are crack, spell, and missing components. Deformation refers to defects that lead to a shape change in facade components. The most common ones are bowing, bulging, and displacement. The third category covers defects such as water leakage, corrosion, rust that can be identified by surface color or texture change. These identified defect lists can be used to generate a comprehensive checklist for the inspection guidance. To enable the model-based customized checklist generation, we propose a checklist generator class. This class is needed to identify applicable defects to a given facade component. The type of component defines the applicable defects to be checked by inspector and the defect attributes to be collected in the inspection process. For this purpose, a mapping matrix has been defined and used by the checklist generator. To enable the flexible information regrouping, the regrouping method class has an enumeration of preference to restructure the inspection findings, either based on facade component hierarchies or based on the defect classifications, or a mixed version defined by the inspectors. This class has a relationship with building class, as this is defined at once for all the facades of a building to be inspected. Regrouping patterns is also a class defined in the ontology to store a preset hierarchy of facade elements based on the regrouping preference. This class will speed up the regrouping for data retrieval. Regrouping method is selected by an inspector to store and visualize inspection findings will have a relationship to the present patterns stored in the regrouping pattern class. So to sum up, this paper is an outcome of an ongoing research. We identified requirements for the model-based facade inspection and developed ontology based on the identified requirements, classes and the representations needed for facade and facade decompositions, for checklist generations, and data regrouping are presented here. Currently, we are working on developing functional prototypes that implement this ontology as an underlying data schema to generate the customized inspection checklist and data restructuring. The case study and the results will be presented in the following up journal version of this paper. Thank you for your time and attention.